All right, so we're going to look at the following examples involving limits. So let's evaluate the limit as x goes to 0 of e to the 2x minus 1 over x. So the first thing I'm going to do is plug in 0. I get e to the 0, which is 1. 1 minus 1 is 0 over 0, which means I can use L'Hopital's rule here for this problem. So when I use L'Hopital's rule, I like to mark my answer so I know I use L'Hopital's rule. I mark above the equals. I'll write L apostrophe H anytime I use L'Hopital's rule. It's the limit as x goes to 0. Now you're going to take the derivative of the top and the derivative of the bottom. So the derivative of x is just 1. And the derivative of the top, you're going to have to use the chain rule. It'll be e to the 2x times the derivative of 2x, which is 2. So now I can plug in 0, and if you plug in 0, you'll get 2 for this limit. All right, let's look at another example here. Evaluate the limit as x goes to infinity, ln of x over x. So if I look at this limit as x goes to infinity, the numerator is going to get larger. It's going to go to infinity. And then the denominator is also going to go to infinity. So I get infinity over infinity, which means I can use L'Hopital's rule here. So the limit as x goes to infinity, ln of x over x, using L'Hopital's rule, it's going to be the derivative of the denominator is 1. The derivative of the numerator is 1 over x. And so now I'm just looking at the limit as x goes to infinity of 1 over x, which is 0. Okay, let's look at one more of these limits. So let's say I want you to evaluate the limit as x goes to infinity, e to the negative x times the square root of x. Well, if I'm looking at this limit, the first part, it's going to have a negative exponent, which really means it's in the denominator. So I'm looking at 1 over e to the x. That's going to get closer to 0 as x goes to infinity. So I'm getting 0 times, and then this square root of x as x goes to infinity, that's infinity. Now this is a different indeterminate form. It's still an indeterminate form, but I don't know what this limit is going to be because it's not 0 times a number. It's 0 and infinity. So they're kind of, again, like two competing forces. And you want to know which one's going to win, which one's going to overtake the other. And so we've got to modify what's here so we can use L'Hopital's rule. Well, L'Hopital's rule has a division going on. It has a numerator and denominator. So what we're going to do is we're going to move that e to the negative x to the denominator. It'll become an e to the x. And now if you look at this limit, in the top you're getting infinity, and the bottom you're getting infinity. So now you can use L'Hopital's rule. The derivative in the top will be 1/2 x to the negative 1/2. The derivative in the bottom will be e to the x. And so if I rewrite this, put everything where it goes in the denominator, this will be 0 for this limit. And you're going to do this anytime you get this indeterminate form where you get 0 times infinity. You're going to rewrite it so that it's a division, And you should either have infinity over infinity or 0 over 0. And then you can use L'Hopital's rule.